Fourier transforms. Find the complex Fourier transform of the function. First question. Find the complex Fourier transform of the function. The first problem is f of x is equal to 1 for mod x less than or equal to a, 0 for mod x greater than a. Hence evaluate 0 to infinity sin x by x. This is the first problem. So you start that we know that f of u is nothing but minus infinity to infinity f of x e to the power of ux dx. So consider this one. Mod x is less than or equal to a, meaning mod x can be minus x or it can be plus x, but mod is always plus. So what they are telling is x is less than or equal to a. X consider some value x is equal to a. It is less than or equal to a. For greater than a, that is this one, mod x. X means it can be positive x-axis minus negative x-axis, but mod x means always positive. Take this side of x is greater than 0. A is 0 here. The function is 0 here. So from here to here, they are considering the value. So you have to consider this part minus infinity to infinity. F of x is what? 1. E to the power of x dx. Understood? So now integral minus a to a. X is both less than or equal to a. Less than a means minus a, equal to a means a. So e to the power of iux dx. So integral of e to the power of ax dx is e to the power of ax by a. Since this is definite integral, no need of putting plus c. Okay, e to the power of what? Iux. This is constant. So iu integral minus a to. Understood? This is how to solve the problem of f of x is equal to for x less than or equal to a, 0 for mod x greater than a. We have to evaluate this. First copy this. This is how to solve it. Now I will rub this problem. Okay, I will keep what is needed. That's all. So, this also I will rub. This also I will rub. Now, when you integrate with values, that is definite values, always keep the constant out. Otherwise you will go wrong. Right, bigger one. 1 by iu. Now you supply the value for x. e to the power upper limit minus lower limit. Minus is in formula. E to the power of I u a minus e to the power of upper limit minus lower limit. So I u minus upper limit minus lower limit. 1 by I u e to the power of I u a minus e to the power of minus I u a. Okay. Now what you have to do is just observe everything. You will come to know how to do this. So upper limit minus lower limit is happening. 1 by I you have to simplify. Fact, this is rationalization. You cannot keep I in the denominator. It has to be rationalized. I is there, multiply by I and divide by I. Nothing will happen to this. So I by I square. As you know, I square value is minus 1. So this is minus I. Plus into minus will be minus I. So I will put this minus I in the numerator. Let the u be here. Now e to the power of I u a is exponential form of a complex number is. This is exponential form of a complex number. Cos theta plus I sin theta. E to the power of minus I theta cos theta minus I sin. So we shall use this here. So e to the power of I theta, I u a is nothing but I is here. This is the term you have to use for that. Cos u theta plus I sin u theta. Okay, minus is there. Be careful. I will rub this. Okay, it will be there in the video. Just go after that. So minus cos u theta. Minus is there. Minus I sin u a. Sorry, it's not theta. U a. It's not theta. U a. This is u. Okay, fine. This is right. Now put the bracket here. Minus I by 2. Just consider this u a plus I sin u a minus cos u a minus into minus is plus sin I sin u a. So we can see this minus I by u. This is I plus I is 2I sin u. So cancel this. Now again I into I will be I square. So let us consider this 1 by u minus 2I square sin u. 1 by u, as you know, I square value is what? Minus 1. Substitute that. U minus 2 into minus 1 sin u. Minus and minus it will become plus. So 2 by u sin u. So keep 2 as it is, sin u by u. This is how to get the problem. For that, what we have defined in the problem, this is the Fourier transform. That's why it is f of u. The function has changed from u to x to u. So this is the answer. We have to derive this. So copy this. I shall derive that also. Finished? Last question. See, the question does not mention here, you have to find Fourier transform as well as inverse Fourier transform. By looking at the limit and what is given, what you have to evaluate, you have to calculate 0 to infinity sin x by x dx means they are asking inverse Fourier transform. Whatever you got the Fourier transform here, from this answer we have to arrive at that. So what I will do is, now we know that inverse Fourier transform is from 0 to infinity. You should know that inverse Fourier transform is from 0 to infinity. So what you have to get is, you have to get the function back, f of x. You get the 0 to infinity, f of u e to the power of inverse minus iux. This is du. This is how to solve the problem. Okay. Now what we shall do is, so whenever you want inverse Fourier transform, you should know that. So inverse Fourier transform is from minus infinity to infinity 1 by 2 pi. This formula you should remember. So it is from minus infinity to infinity, it will be like that. But they have asked 0 to infinity. I should have done directly, but learn this. This is important. Minus infinity to infinity is, there is a continuous function. Minus infinity to 0, 0 to infinity. Continuous. But they have left this part because there is no answer here. Answer is from 0 to infinity. So we have to consider 0 to infinity for our answer. But inverse Fourier transform is always f of x is equal to 1 by 2 pi minus infinity to infinity f of u, you got here, that 1 e to the power of minus iux d. Understood? This is how to do the problem when it comes for inverse Fourier transform. So now we will go for the same old formula. What they have given, we will find that now. Okay? This is how to solve it. So once you know this, you have to evaluate that according to this. Now we shall not drag this video forward. What we will do is, we will solve everything from this angle. If you see this, you should know that you have to calculate that. For that, what we will do is, so f of, we will write that 1 by 2 pi minus infinity to infinity. F of u is 2 sin ua divided by u e to the power of minus iux dv. So 2 get cancelled. Will be 1 by pi minus infinity to infinity sin ua by u e to the power of minus iux. Understood? It's fine. Now you have to know that what is the norm to find it. See, what they have done is, so since x is equal to 0, where you can see here, x is equal to 0 for what? For mod x less than e. For mod less than e is this minus infinity. So it is, the problem is telling that you have to put x is equal to 0 here, because minus infinity is not valid here, because mod x in the problem they have given mod x is less than e. Okay. Now what we shall do is 1 by pi, this is 0 to infinity, sin ua by u see, put x is equal to 0 here. So what will happen? F of x is what? They are given 1. F of x is equal to 1. There is no variable to put here. For f of 0, it will be 1 only. If some term is there in x, we should have supplied that here. Since f of x itself is 1, a constant, so f of 0 will be 1 only. So f of 0, f of x is this side. Okay, this will be, after putting, we have to put x is equal to 0 here also. Here also. So be patient. F of x, f of 0 is equal to 1. Is equal to 1 by pi. 0 to infinity. Sin ua by u e to the power 0 equal. If you supply x is equal to 0, it will be 1. Understood? So this is how to solve the problem. 1 by pi, 0 to infinity, sin ua by u. So take down this. Since e to the power of 0, any number raised to the power of 0 is 1, so we will do this. Okay? So after this, we will do the next step. The next step is very easy. We have to evaluate this term. What is the answer? So now, take this 5 up. Pi is equal to 0 to infinity sin u by u d. Now observe, put a is equal to 1 here. So you will get 0 to infinity sin u a by u d. Change u to x. One term we have missed here, that is, you should know that from minus infinity to infinity, if you forego minus infinity, you have to put 2 here in the answer. Why? Because we have learned in Fourier series that from minus infinity to infinity, if you want to cancel this minus infinity, for that adjustment you have to put 2 times here. 2 for 0 to infinity, you have to put this one. You can multiply. So, for everywhere you do this, then what happens? This will be again pi by 2. This is pi by 2. So, change u to x now. Simple. After changing, what happens? It will come down to what? After putting a is equal to 1, this problem has told us there is no coefficient called a here. The coefficient of x is 1 here. So I am putting a is equal to 1. Then changing to u to x will become what? Pi by 2 is equal to 0 to infinity sin x by x. This becomes dx. So the value of this is what? Pi by 2. This is how to solve the problem. Understood? So in the next video, I will be doing those problems which are very difficult. So till then, bye. So these people make noise in between, and the tak will be recorded here. Finished?